Hello everyone, in this video we will discuss about BCD adders, and in the next video we will see how to implement a BCD adder using IC 7483 with Proteus software. In binary coded decimal or BCD, we will be representing each decimal digit by a binary value, or we will be representing each decimal digit by a binary code of 4 bits. So there will be only 10 code groups in BCD system, that is from decimal digit 0 to 9, that will be represented in BCD system. So in the case of binary, with 4 bits, 16 combinations are possible. That is, we can represent decimal numbers 0 to 15 in binary. Whereas in the case of BCD, we can represent only 10 code groups or 10 combinations, that is from 0 to 9. And the next 6 combinations, that is from 10 to 15, these states are invalid in BCD. We can't represent them with 4 bits in BCD. So we will be representing each decimal digit by a 4-bit binary value. So in the case of if the decimal digit is 10, we will be representing it in binary as 1 will be represented in binary as 0001 and 0 will be represented as 0000. So this is the representation of 10 in BCD. We cannot represent 10 with a 4-bit value in BCD. And 11 can be represented as the decimal 1 can be represented in BCD as 0001. So 11 can be represented as 0001, 0001. Similarly for 12, 13, 14 and 15. So this 6 states, that is 1010, 1011 to 1111 is invalid in BCD. And the most commonly used BCD code is 8421 BCD code. There are other types of BCD code like 2421, 5421, etc. But the most predominant code that is used is the 8421 BCD code, and whenever we refer to BCD code, it will always be the 8421 BCD code unless otherwise stated. And 8421 represents the positional weights. So it indicates the binary weights of the 4 bits. 1 corresponds to the weight of the LSB and 8 corresponds to weight of the MSB. So now next we will move on to BCD addition. So we can add two BCD numbers using the same rules for binary addition, and there arises 3 cases when we add two BCD numbers. The first case is when the sum is 4-bit sum is less than or equal to 9 and carry is equal to 0, then the result will be a valid BCD number or the answer will be correct. And another case is that if the 4-bit sum is greater than 9 or a carry is generated. So that is written here as the second case, that is sum is less than or equal to 9 but a carry is there. So a carry is generated, or if the sum is greater than 9, then the result will be invalid. So in order to get the correct answer, what we have to do is, we have to add 6 to the 4-bit sum. Why we are adding 6 is, we have to skip the 6 invalid state and return the code to 8421. So we are adding 6. So we have to add 6 to the sum in order to get the valid BCD. So we will see an example. So we are going to add 2 and 6. So we are going to perform BCD addition. So the sum when we add 2 and 6, we will be getting 8. So we have added the 4-bit numbers to 4-bit binary representation of 2 and 6, BCD representation of 2 and 6, and the result we have obtained is 8, and the sum is less than 9. So that is case 1, and there is no carry generated. So the answer is correct. This is a valid BCD number 1001. And next case is, we are going to add 9 and 8. So the answer we have answer which we will get is 17. So let us look that. So 9 is 1001 and 8 is 1000. So here when we add these two, When we add this to 1 plus 0, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 1 is 0 with a final carry. So, the sum here is less than 9, that is it is 1, but there is a final carry. So, this result is invalid. So, in order to correct this result, what we have to do is, we have to add 6 to the sum. So, we have to add 0, 1, 1, 0 to this sum. So, this becomes 1, 1, 1, 0 and this 1 over here. So, this represents, this is 7 and this is 1. So, it is 17. So, 8 plus 9 is 17. So, we have obtained the correct result. So, this answer was not correct, and in order to correct that, what we have done is we have added 6 to the sum. So, it becomes 1, 7 and the answer is now correct. So, this is the second case. Now, the third case, that is when the sum is greater than 9. So, let us consider this example, that is we are going to add 7 and 6. So, 7 is 0, 1, 1, 1 and 6 is 0, 1, 1, 0 in BCD. So, we are going to add those two numbers. So, what we will get is 1 plus 0 is 1. 1 plus 1 is 0 with a carry 1. This is 1 and this is 1. So, this is equal to 1, 0, 1, 2, 4, 8. So, this is equal to 13. And so, the sum is greater than 9 here. So, this is an invalid BCD number. 13 is not there in BCD. So, what we have to do is, we have to correct the answer. For that, what we have to do is, we have to add 6 to the sum. So, we are going to add 6 to 1101. So, when we add 6 to 1101, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1, 1 is 0 with a carry 1, 1 plus 1 is 0 with a carry 1. So, the answer is, this is 3 and this is 1. So, when we add 6 and 7, we will get the answer as 30. And here the answer is, this is 3 and this is 1. So, the answer is correct and this is a valid BCD result. So, this is how we will perform the BCD addition. Now, we will see how to design a BCD adder using IC 7483. This is the pinout of IC 7483. So, we can connect the origin over here and the addend over here. Then the result sum will be obtained in this pins and 14 is carry out. Then we can connect plus VCC to 5 and ground to 12. Then 13 is the carry input. So, if there is no carry input, we can connect that to ground. So, we will see how to implement a BCD adder, how to design a BCD adder using IC 7483. So, this is IC 7483. So, we are going to add two BCD numbers. We'll be giving that to A4. We will be giving the origin to say A4, A3, A2, A1 and the addend to say B4, B3, B2, B1. So, we are taking the MSB as A4 and B4 and LSB as A1 and B1. Now, the result will be S4, S3, S2, S1. This will be S4, S3, S2, S1 and there will be a carry also, carry out, C out. That is shown over here, carry out. Now, so we are adding two BCD numbers here and we will get a sum over here. And if it is a valid result, it is okay. This will be the final value. And if the result is invalid, if it is an invalid BCD, that is when the sum is greater than 9 or when a carry out is generated, then the result will be an invalid BCD. So, in order to make the result correct, we have to add 6 to the sum. So, we have to use another 7483 IC. So that we are giving S4, S3, S2, S1 to say B4, B3, B2, B1 of this IC. And when the result is invalid, we have to add 6 to this sum. So, 6 means 0, 1, 1, 0. So, A4, A3, A2, A1. Here we have to add a 6 when the result is an invalid BCD. So these two are zeros. A4 and A1 are zeros. So we can connect it permanently to ground. Now these two, A3 and A2, should be 1 when the result is an invalid BCD, and if the result is a valid BCD, then we should get the same sum at the output of this. So the S4, S3, S2, S1 should be equal to the same sum that we have obtained earlier. So for that, this A3 and A2 should be equal to 0. So that A4, A3, A2, A1 becomes equal to 0, 0, 0, 0. So we'll get the same sum at the output of this IC when the result is a valid BCD. So we have to design a circuit which produces a 1 when we get an invalid BCD and which produces a 0 when we get a valid BCD. So we are going to design that particular circuit. So we have to connect a particular circuit over here such that this produces a 1 when we get an invalid BCD and a 0 when we get a valid BCD result. So let us consider, let us design that circuit which has to be implemented over here. So that is, when the sum is greater than 9, we will be getting an invalid BCD result. So sum is greater than 9 means the 4 possible states are S4, S3, S2, S1, and let the output be say C. So when the sum is greater than 9, that means 10, 11, 12, 13, 14 and 15. So 10 is 1, 0, 1, 0, 11 is 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0 and 1, 1, 1, 1. So if this 6 states comes, then the output should be equal to 1. That is, these 6 are invalid states in BCD. So if the result is 10, 11, 12, 13, 14, 15, that is 1, 0, 1, 0 to 1, 1, 1, 1, we should get a 1 at the output. So let us consider a 4 variable K-map, and if it is from 0 to 9, the carry out should be, this output should be equal to 0. Okay, so let us consider, let us construct a K-map, 4 variable K-map. So this is the 4 variable K-map, and let this be S4, S3, and this is S2, S1. So here this 6 invalid combinations, for the 6 invalid combinations we should get a 1. So that is, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So it should be 1 for sum greater than 9. So for 10 it should be 1. So here it should be 1, 11 it should be 1, 12, 13, 14 and 15. So we can do the simplification of this K-map. So we can group this 4 ones together, and we can group this 4 ones together. So the expression which we will get is, here it is S4, S3, and here in the, for this 2 rows S2 is common, and for these 2 columns S4 is common. So this corresponds to S4, S2. So we can write C is equal to S4, S2 plus S4, S3. So here we are going to design a circuit which produces a 1 when we get an invalid BCD, and which produces a 0 when we get a valid BCD. So invalid BCD is from 10 to 15, so it should produce a 1. So we have drawn the K-map and we have simplified, and we have got the expression as S4, S2 plus S4, S3. That is, when the sum is greater than 9, we got the expression like this. And there is one more case also, that is when a carry out is generated. Also, then the result will be invalid. So that we have to take into account that also. So for that, what we can do is, when a carry out is generated also, the output should be equal to 1. So we can write the expression like this: C is equal to S4 S2 plus S4 S3 plus C out. Or we can write C as S4 into S2 or S3 or C out. We can implement this circuit over here. So this circuit will produces a 1 when the sum is greater than 9 or when a carry is generated. So C is equal to S4 S3 or S4 S2 or C out. So we can implement this using, this can be implemented using an AND gate, and OR gate. Or what we can do is, we can simplify this like this: S4 into S3 or S2 or C out. So first we can give an OR gate, then we can give an AND gate, and finally we can give another OR gate, 2 input OR gate. So we can do like that now. So S3 and S2 are ORed. So the output is S3 or S2, and this is ANDed with S4. So the output of this AND gate will be equal to S4 and S3 or S2 and the C out also. We have to OR these two things, that is S4 and S3 or S2 is ORed with C out. And this should be connected over here. So this is also given as C out over here, the final carry. Okay. So this is our BCD adder using IC 7483. So in this circuit, what happens is that, so let us consider two numbers, say 4 and 3. We are going to add 4 and 3. So the result will be 7. So 4 is 0, 1, 0, 0 and 3 is 0, 0, 1, 1. So when we add these two, we'll get 7. So the sum is less than 9. So what happens is that, here we are giving 0, 1, 0, 0 and here we are giving 0, 0, 1, 1. So the output will be 0, 1, 1, 1, which is less than 9. So the output of this will be S4, S3 or S4, S2 will be 0 and there is no carry out. So C out will also be equal to 0. So we'll get 0 over here. So at A3 and A2 it will be 0. So A4, A3, A2, A1 will be equal to 0. So whatever is the sum, that will get over here. So the output here will be equal to 0, 1, 1, 1. That is the first case. Now the second case is when the sum is greater than 9. So that is, let us consider another example, that is 8 plus 4, that will be equal to 12. So 8 is 1, 0, 0, 0 and 4 is 0, 1, 0, 0. So if we add these two, we will get at the output 12. We'll get like this. So 1100 is invalid in BCD. So what we have to do is, we have to add 6 to this sum. This sum is greater than 9. So this result is invalid. So we have to add 6 to this sum, 0, 1, 1, 0. So our answer will be, this is 2 and this is 1. So this is 12 in BCD. So when we add 6, we'll get a valid BCD result and the result will be 10010. So let us check that over here. So if we are giving 8 over here and 4 over here, then the sum will be equal to 1, 1, 0, 0. So this 1 1 0 0 is an invalid combination. So here the output will be equal to 1, and so the output of this OR gate will be equal to 1, and here we will get 1 at A3 and A2. So A1 and A4 is 0 and A3 and A2 is 1. So we will be adding 6 to this sum. And the answer will be, we are taking this carry out over here. So the answer will be, here it is 1, here it will be 0 0 1 0. So we will get the correct answer at the output. Now let us consider the third case, that is when the sum is less than 9 but a carry is generated. So let us consider 8 plus 7. Let us consider 8 plus 9. So 8 plus 9 is 17. So 8 is 1000 and 9 is 1001. 1001. So if we add these two numbers, we will get 1 plus 1 0 with a carry 1. So this sum is less than 9, but a carry is generated, and this carry is equal to 1. So if we look over here, the output of this will be equal to 0, but there will be a 1 over here. So this 1 will come as the output, and that will be coming over A4, A3, A2, A1. That means this becomes 6. So 6 is added to the sum, and we'll get the result, and we will get the valid BCD result. So let us check that. So here this is an invalid result. So in order to make this valid, we have to add 6 to this. So 1001 plus 0110. So that is 1 1 1 0 and 1. So this is 7 and this is 1. So this is a valid BCD result. So we are taking this carry out over here. So this is 1 and the result will be 0 1 1 1. So we'll get this as the result when we add 8 and 9. So 3 different cases. So this is all about BCD adders. Thank you.